So from tower, I'll project a particle with a kinetic energy K. Or let me write that initial velocity t equals 0 having mass m. So it's going to describe a path and it'll come and strike the ground. So when it strikes the ground, it will have x component, y component. I think this is a time of flight. Tau is what is giving, and there's a range. There's some viscous drag is also present. So let's go for at any time t. At any time t, when the particle is here, what are the forces that are acting? Mg. The viscous drag, how the viscous drag should act? Then it is having x component and y component. These are the final. At any time t, this is a situation. What was the initial kinetic energy? It was given for us, K. So therefore the K is what? Mu square by 2, U equal to 2K by M. So where all needed, that is the initial velocity it was projected. Let's get into the problem. Find the horizontal range of the ball. It's asking to get expression for R in terms of that K, and the force of A drag is proportional to speed V. Proportional is telling, only there is information what we have. So it's a definitely viscous drag. So the viscous drag should be equal to alpha V. That alpha we don't know, that we'll try to determine.
Give, sir.
Proportionality constant is K. Oh, it's available, no? Yeah. I didn't see it. I'll make it alpha because that small K, capital K. Let's get into this one. Yeah. Okay, see, we are discussing horizontal projectile with viscous drag. There's only the concept of this one. Nothing big is there. So at any instant of time, so let this be the theta. So therefore, this will be theta. Now, so what is the retardation along x-axis? Ax should be equal to minus fv sine theta by m. So the viscous drag is equal to, this will become alpha v sine theta by m. This ax, I'll write it as v dvx by x equal to alpha v. Alpha v it is speed v sine theta by m. So what is Vx? Vx should be equal to speed of particle is v. So Vx should be equal to v sine theta. Simple problem. Only thing is we should take care of the mathematical conditions very clearly. So minus alpha m. This will be dx. So from here, I'll bring expression for the range. Initial velocity, how much it is given? It is u naught. Finally, it is vx. Here, the horizontal range will be 0 to capital R. This is what being asked us, no? Vx minus u naught equal to minus alpha r by m. Keep this equation 1 in hand. The same ax, which is there, so this can also be written as dx dvx by dt, because we know time of flight, no? So this will be dvx v sine theta. V sine theta, what you can write it as vx. So dvx by dt minus alpha by m into vx. Initial velocity of the particle u naught. Finally, it is vx only. This is tau. So this will become log of vx by u naught minus alpha tau by m. Or what is the value? Vx equal to u naught e to power of minus alpha tau by m. So that Vx we don't know. So that I'm going to substitute there. So from solving 192, Vx value will be u naught u naught e to power of minus alpha tau by m minus u naught minus alpha r by m. So the expression for r, one more step, I think we'll get it. This one, u naught m by m u naught by alpha can be asked. Simple mathematics. I think somehow we should analyze that tau and r is given, no? So taking help of that tau and r, if it gives height, I would have took the y component. Since we have information about only the x component of velocity more, that's why I just took help of x component of velocity. Purely, I think may not be less concept, the more about the basic idea that one. So that there's some, what methodology you're going to take help of here. The information what we have is like a some tau. Okay, so then I'll bring h. Okay, you can, since you know tau, you can bring also for h. Take y component of velocity and get into the problem. Since what we have, see, why I'm taking it is like the x component of initial velocity is what we know. So therefore, I just took x component of acceleration. I just carried on the problem. And these are very important in advance. So just wanted like students, how we'll manage things. This will be really time killing. You solve by take y component or x component. Since we have information of range, no, the limits will be very easier. Since you have tau, then you have to make a guess of height, h equal to half g tau square. Then from h you should bring tau. Then you have to solve. Then component of viscous drag, you have to take it here in this direction. Then I think it'll be complicated. You see, along y-axis, why I'm trying to avoid is like mg minus fv sine theta equal to may. The integration will become very lengthy for you. Therefore, I just took help of motion along x-axis only. I analyzed it. We have other problems. Okay, tomorrow we'll continue from here. Tomorrow, I think will be the last